So generics was this feature that was introduced in Java quite early. And the main idea is that you want to be able to set up these classes that would be flexible enough to work with different types. So for instance, one typical use of generics is when you have a container, a data structure where, let's say, you have a list, you have a sequence of things, right? And then each element in that sequence is an object of some type. And then based on just the vanilla use of the language that we have seen so far, we would actually need to create one new class, at least, every time that I need to create one new data structure that would support that given target type. So for instance, if you have an idea of a list of integers, right? And then you move to a similar list, but instead of integers, you're gonna store, let's say, strings, you would need to have another class to be able to do that, right? Or you could actually go with a design philosophy of treating your underlying instances as of type object, and then just hiding the type, right? So you would always be doing these kind of castings and conversions and just requiring anything to be an instance of object. But then there's a major problem if we go with that approach, which is if I consider any instance of object to be valid, that means that I'm no longer type checking at all, right? So I'm completely bypassing any possible type checking. So for instance, if I want to have a list of integers, I would expect every single element of that list to be integer, right? So that's one example of type checking that I would want to do. If you just require that instance to be of object, you just lose that ability, right? You can no more actually check if that's the case, right? At least the language is not going to do that for you. So it just misses one major feature of the language altogether, right? This would be one example where we could make a declaration of a type parameter. So the way that we use generics is initially by declaring type parameters. So a type parameter is, as the name implies, just a type of a parameter. So it's just it's kind of the idea of a regular parameter, but what you're specifying is a type, right? So not really passing data instances associated with it. Instead, so for instance, here you have an interface. You could do that with classes or interfaces, by the way. You would have an interface that somehow models a queue, and that queue would be a queue, of course, of elements of type E, right? What is E? When I actually go and create an instance of a class that implements the interface, I go and tell what E is. So not right now, just later down in the code, I'm going to go ahead and do that, right? So when I actually have the need to create an instance of a class that implements the interface, that's when I'm going to go and specify what that type is going to be, okay? In this example here, for instance, you would have this idea of two abstract methods required, right? And then that's Zoom or Discord. Yeah. So let's actually take a look at an implementation of this idea of that queue, right? Same as before, we have that declaration of an interface queue, right? The type parameter is specified here. And then notice that we have these two abstract methods here that already make use of that type parameter, right? In different ways. So here I have an enqueue method that takes an item, right? So I'm gonna add something to the queue. That's the idea here. That something is the item that I'm gonna add. The type of the item is my type parameter, right? Is E. So of course this E needs to match whatever you chose here, right? So that's how the syntax makes sense, how the compiler makes sense of what that E actually means. You cannot just skip that and then just use E out of nowhere. That's not gonna work, right? So you need to declare beforehand what the type parameter is, then And that's done by using that diamond syntax, right? The smaller type parameter, greater. We typically call that the diamond operator. That's how I tell that I'm going to use that type parameter, okay? Here, in the enqueue method, I have set that type parameter to be a return type, as you see here. So there's no difference in the regular sequence, the regular syntax, when I declare that abstract method. Where I would otherwise put a type, I just put that E there, right? So where I would put a return type, I just put that E, okay? So for instance, if that would actually be an integer, I would have integer here instead of E, okay? If this is the first time that you are seeing this syntax, it is a little bit odd. It is a little bit kind of alien, right? But you will get used to it, right? Especially in those more simple cases, that does make a lot of sense and does create a lot of flexibility. Because as I said, the main use of the generics is just for us to create a smaller number of classes, just a class that is more flexible and would be able to work not only with one specific type, but with a variety of different types, right? And the typical use case is, as I mentioned, with the data structure related classes, right? Sequences, lists, arrays, dictionaries, hash maps, and so on. So these kind of things, trees, okay? The second example that we have here is the dequeue, right? So the dequeue, sorry, actually I mentioned that would be the return type. That's not true. Here the E is the return type, right? Here the E is the parameter type, but that's another example of using E. With dequeue, that means that you're gonna remove that item from the queue, and then that type is gonna be following that E here. Again, that's the type that you have specified when you create an instance of a class that implements that interface. Okay. Here's an example of using that interface with a class, right? So that's just the initial declaration of the class that you see here. So in my class, I specify that my type parameter E is going to be the type parameter that is going to be used. So I can use that in the declaration itself, as you see here. And you can see on any following member as well. So you'll see some additional examples. Any member of a class or an interface that is declared with type parameters can use those type parameters. All right. When is it that you cannot use? When you don't declare the type parameter. If you don't declare the type parameter, then perhaps obviously you cannot really use it. Okay. Any questions so far? We're going to see some more examples. How do we name those type parameters, right? So by convention, we would go with one of those letters, so just one single letter, right? These letters comes from these terms here: element, key, number, type, value. So for instance, if you would have a mapping structure that maps a key to a value, then you need two types, right? So that would be one typical use of the K and the V, right? Because we typically refer to that pairing as the key value pair or the key value mapping, right? So then you would go with K and V if that's just a number, and if that's just a general element E, general type T, and so on, right? So really just convention. This is an example of a class that uses a type parameter. So here I'm specifying a class box, and in the declaration of the class, I specify the type parameter, right? Again, the way that I specify the type parameter is the diamond operator, okay? After I do that, then any member of my class can make use of that letter that you have chosen. All right, so you see here a field that uses it. That's fine, no problem. You see a method and another method that uses it, right? So the type of the field here, you see that it's using that type parameter. The type of the parameter passed as an argument to that set method is used as the type parameter, and here the return type is used as a type parameter. So when you actually go ahead and declare an instance of a box, let's say, you would need to follow these syntax that you see here. Okay, so notice that here in the type of the variable, I am declaring a variable, right? So in the type of the variable here, I am specifying the concrete type that is going to be sort of replacing that placeholder that is my t, sorry. And then you need to call the constructor. The call to the constructor you can do as you see here, where you again specify the type parameter, right? So then in this case, you would need to, of course, match the same type parameter here. But there's also the possibility of just implicitly calling the constructor as in here. So it is also possible to use this sort of shortcut. So in the constructor call, you actually don't put the type parameter there because in the type of the variable, you have already done that. So then the compiler knows that because you have specified that string box as a box of strings, so then necessarily this is calling the constructor and passing that type parameter string as well. So this is just a shortcut. It's used very frequently, very popularly. There's nothing wrong with it. Actually, I like the idea very much because at some point you're just repeating what you have already said, right? And it's a pretty easy inference that the compiler actually need to do to do that. So so there are instances, right? But these are only when we talk about what we call bounds, right? So with bounds, there will be some cases where I don't need to do that match, right? With the generic type parameter, I don't have the same is a relationship applied the same way that we have seen before. Right? So for instance, here, if I would have a superclass of integer, I could not use as a type parameter here. Okay. Generally speaking, there's some exceptions when you talk about bounds. We are going to see some examples of that, maybe not today, but we're going to see some examples involving generic bounds. And then you see that in some cases, actually you can do something similar to what you would have when you use that is a relationship, right? It's not the same thing, but it is somehow on a high level similar. Mm-hmm. Yes. So so the constructor is typed here. So there's a type matching happening between these declaration that I have here, right, and the type of the parameter, right? That's actually the main case where that's going to happen. Okay. In some instances, we will see some examples involving methods. I can also declare methods where I specify in the method level a type parameter, right? So in that case, the method is going to be doing some type checking as well. So far, we did not see that. So far, we only see this example of type checking, right? But that's the main case where the type checking is actually going to happen. Another thing that I did not say yet, but I'm going to say now, is that the type checking that the generics do is always a compile time check. Okay, so that's a very strong statement that I'm making here, and that's really because that's universal. So the type check that the generics framework is capable of doing happens only at compile time. Okay, that's equivalent of saying that if you try to make any type checking during runtime, no, sorry, generics cannot do that. Okay. We will detail a little bit more about that. Again, maybe not everything today, but I think we'll have some examples that somehow involve that, right? I can actually comment that right now. So after you compile your program, and you have of course a program that uses generics, right? So what actually happens is that the compiled version of your program, so the bytecode generated from the compilation, will not bring that type information that you have actually used, right? So most of the time, what's going to happen is that the variable, the instances, the things involved that are going to be created in memory are going to be typed as object class. Right? So most of the time, that's actually what is going to happen with the bytecode, right? There are some exceptions, and I'm not going to talk about the exceptions right now. That's also related to the bounds. In the future, I'll talk about these exceptions, okay? So yeah, so you can do that. This is a comparison that is very interesting, showing a piece of code that would not make use of the generics, and then we call that sort of the old version, and the new version, right? And that's kind of justifying the main benefit of the use of the generics, right? So let's take a look at what we have here. So here I am declaring a variable using a list. So here a list is not a list of something, it's just really a list. And if you have observed or if you have actually worked with any kind of list, as for instance an array list, which I believe you have, then you probably got used to using something like what you have here, right? So these syntax where you suppress the diamond operator is still valid nowadays, okay? Even though, as I will comment in a bit, not recommended, but this is still valid syntax per current version of modern use of Java, right? So, and the main reason why we have that is just really to make it backwards compatible with whatever you had before, which is actually quite old at this point, but whatever. So here I'm just creating that variable. I'm calling the constructor of linked list. Here I'm not saying what linked list is made of, right? So each element in that linked list is what? I'm not saying, right? So then I go and add a number, an integer here to my list, right? And then here I could iterate over that list. So here, I don't know if you have actually saw that before. One of the interfaces that we will be talking about is the iterator and the iterable. So the iterator is just a way for us to iterate over elements, right? So if you have like a sequence of things, as for instance in a list, you have just a sequence of objects, right? So you could actually rely on that iterator to traverse that list of elements, right? Every time that you want to access the next element, you go and call next. All right, so that's what we are doing here. We're just having access to the first element of that list by using that iterator that is associated with that list, okay? We don't have to get into too much details right now. We're going to see in the future how that works. Whatever I get here, I don't know actually what the type of that return is going to be, right? So in other words, each operator, each element, sorry, each item of that list is just going to be an instance of object, right? There's no type checking at all being performed to guarantee any type that would be applied to that element. So I'm talking about this element that I have added, right? So far we only have one number added to that list, but still I would need to rely on casting to be able to guarantee that I'm going to treat that element as a specific type. So in that particular example here, I would require the use of casting to be able to treat that as an integer or anything, any specific class. Okay? And of course, if you cast that as an integer, now you can assign that to a variable that follows that type. All right? So that's a very simple example, right? Just a list, I add one element, and then I retrieve that one element that I have. And finally, I store that one element in a separate variable typed with that type that matches the type of the item that I have added. All right, so how does that work with the new version, with the actual use of generics? So here, I am specifying that my list is a list of integer. So what do I get if I do that? I get type checking if I do that, right? So my compiler now knows that that list is made of integers. That's what I get, right? The rest is just the same that we do here, right? I could actually suppress that if I want. That will not make a difference. I go ahead and I add that element, that integer, right? If I would, for instance, try to add something else, I would get one first error. I don't actually do that here. Then I go ahead and I retrieve. I do the same way that I did before, right? I retrieve the element that I have added there, but now I don't need to actually cast that, right? Because my compiler knows that that list is made of integers, right? So when I actually go and call that next, the return type of that next is that integer, right? It's inferred, right? Why? Because my constructor received that information. So when my method is called, then that's actually from the iterator, but still iterator is also just following the same type parameter. So when I actually get that next with the return value, then I'm going to just get that integer information. So then my compiler will know that these actually, that whatever is returned from that next is actually an integer. So I should be good. This is a simpler code to work with, and this just achieves more than what I have done here, right? So casting is generally understood to be a not very good feature to be relying on. Every time that you can just avoid using the cast operator, it's actually beneficial for the maintenance of your code, and that does not need to be paid in terms of like giving up understanding of the code. It's pretty clear. If you understand generics, it's pretty clear that everything that needs to be specified is being specified here. All right. There's a name to that use that we saw here, and I think I have some example that actually explore that as well. That's called the use of a role type. Anytime that you hear about this term, role type, that means that we are just bypassing the generics type checking. Okay, role type means I am not type checking. I am bypassing the generics mechanism. So I'm just ignoring the type parameter altogether. Okay, let's see a little bit more one example that is a slightly more I don't say complicated because it's not complicated, but it's just slightly longer than what we saw before. So we have this interface that is a pair. This is a key value pair. So notice that that convention that I mentioned is being used here. Right, so just a pair of elements. I have these two methods that I declare as abstracts that just returns the key and the value. And notice that I am making use of both of those type parameters here. This is also the first time that I'm using more than one type parameter at the same time, right? So notice that here I'm just using the comma, and I can use as many as I need. You don't have to use just one or two, as many as needed. It's fine. You can go and use it. Then here I declare a class, that's a concrete class that uses the same type parameters in terms of naming, right? And then it says that implements the pair that matches the same thing, right? So my declaration here happens the first time that I use the diamond operator, right? And then here I am just reusing what I have previously declared. So for instance, one thing that I could do is I could implement a class with type parameters A, B, and C, and say that that class implements an interface that takes type parameters as well, but not A, B, and C. It's going to take C, B, and A. So in that case, the order matters, because the first time that I have declared the type parameter was here from left to right, where that first appeared. And then the matching is going to be done based on the identifier. Okay, so the order in that case does matter. At the very end of the course, you're going to see some examples where you actually do that. So here we do the same, right? So we declare two fields, one with the key type, one with the value type, same as what we did before. We have a constructor here that initializes those guys, right? So again, I take as parameters types of parameters, those type parameters. This sounded a little bit confusing, but I hope that makes sense. Then I have some methods that I implement here. Again, I'm making use of those type parameters, right, as my return type. And then here in my main method, I am creating two ordered pair instances. The first one, called P1, is going to be one comprising a string and an integer. And then I pass to my constructor here a string and an integer. So like this would be one example where that type checking would occur. Right? So for instance, you could not flip those two. That would not work based on the constructor that you have seen here. Okay. So that'll be one more example where the order actually matters. Then you have these second one here that we have that shortcut where you don't specify in the call of the constructor the type parameters because they have already specified in the type of the variable. So then the compiler is smart enough to just infer that. So here you have a string and a string. So then it will understand that the valid possible instances here would be string and string. This is just a little bit more complex example where it shows that you could actually sort of nest the type parameter specification. So here my first type of this ordered pair would be string, and then the second one is going to be a box of integer. So the type parameter here is box, but box is a class that is a generics class, so it takes type parameters. So it's perfectly fine for us to specify that type parameter of box in that same declaration there. And you can actually keep doing that as many times as you need. Just be concerned because it's going to be more and more difficult for you to make sense of whatever you have there. It just gets more complicated to make sense of the code if you keep doing that, right? So that's perfectly fine. We have the role types, as I already mentioned that, right? So the use of the role type is just this idea where you suppress the type parameter, right? Depending on how you compile the code, you will get just a warning that will not prevent you from compiling. There's one very common, one very popular flag that you can use that would just be a little bit more verbose in terms of the outputs that your compiler is going to get, and that's the xlint. I don't think I have that in the notes here, but you can just make a note of that uppercase X lint. So that's going to be one flag that you can pass to the Java compiler, the Java C tool, and that's going to be explicitly presenting messages every time that you make use of a role type. Right, so every time that you actually try to bypass, mistakenly or not, right? So you're going to see a warning message. Any questions? All right, so the last thing that we have here in this lecture notes is just an exercise. You can do that at home and then just compare versus the solution that you have here. So please do try to just look at this code here and then try before you look at the next slide. All right, and you can compare and see if you got it. Mm-hmm.
Like what happens with box raw box, box?
Say it again.
When you do the raw box initialization, and there's in the class you need the raw type parameter to create an object inside the class as an instance variable. So what happens?
And if you want to type check, you're gonna type check. Actually, we have an example of that, right? The first. So here, for instance, I have used the role type here. Right? So if I wanted to work with the elements of that linked list, I would need to cast that necessarily to be able to treat that as a specific type. The item itself, yeah, the item. I mean, in this case here, the item could be of any type.
The box
Which example? Last slide. Oh, sorry. If you would, so you're saying if I create an integer instance and I try to add to that box, that was, I'm not sure I get it. So can you repeat the question?
So now when you're creating instance of raw box,
Uh-huh.
you go to the class of box type, in the previous slides somewhere, this box class. Here you have a parameter thing so that it creates an instance of T type.
Yes.
You're not sending that. So
No.
When you
So it's object.
it's default, by default it goes as object.
Yes. So that's why it's going to accept anything. Yeah. All right. So a little bit of a recap from last lecture. I mentioned that generics exist for a number of reasons, but the main reason would be to, allow us to implement classes or interfaces that would be more flexible in the sense that I would be able to specify a type. So that would be the type parameter. So I would specify a class that would be done only when I actually go and create an instance of that given class or that given class that implements a generics interface. And that would be the time when we would be doing that, right? So not really when we declare the class or when we declare the interface, right? So by the time of the declaration, we would be just working with those sort of placeholders, those sort of variables, those identifiers that would just be replaced by that given type, that given class that you actually specify. So that would be one of the reasons why we would want to go with that. One other possible reason would be to eliminate some cases of casting, and I showed you an example that is pretty similar to this one here, where we go from instantiating a list where I don't specify what the type of each element in that list would be, to a form where I go and do that specification. And by doing that, now I have a mechanism that my compiler would be able to go and determine what would be the type of the element anytime that I perform an operation such as retrieve one of those elements or find one of those elements or add one new element or something that would return to me some reference, some instance. So that's what you see here, where we, for instance, retrieve one element from that list, and we don't need to specify that return type is going to be actually string, because that's already implicit based on the implementation of the get that you have on that class. So another thing that I also mentioned with you is that generics allows us to do a type checking. So that's going to be more formally what type of feature that the compiler would be able to use. And of course, if you type check, you have some additional guarantees that the type would be not violating any assumption that you make. So for instance, when you go and just pass and receive object type all around, that means that you're not really guaranteeing that instance follows any specific class, right? And a lot of times that's not really what you need, what you require, what your business logic would actually be setting as a requirement, right? So like in this case here, we would know that we would want to work with a string because we want to assign that to a string variable. So then this kind of checking here would not be able to be performed by my compiler. So I also shown you some examples. These are just revisits of what we have seen before. I also mentioned that we can work with multiple type parameters at a time. So meaning that, for instance, I can declare that I'm going to use in an interface more than one type parameter. And in this case, is an example of two type parameters, one being the key and the other being the value. So that's just the popular idea of working with a pair tuple, where I'm going to have two things part of that pair. One's going to be the key, one's going to be the value, and then you can work, for instance, here specifying what the first one's going to be, what the second one's going to be, and so on. So all that's pretty similar to what we have seen before. I also mentioned that every time that I go and use a type that is already using generics, but I don't specify, I don't use the diamond operator, that is going to be a valid syntax in Java for compatibility purposes. So just to make the code really compatible with the pretty outdated at this point, Java code. So we want really to have a compiler with a current version that is capable of compiling anything of any version that you have available, right? So the compatibility is, of course, from the more recent version to the oldest one. We don't want to break things, right? That's pretty much the idea. But when you do that, you are really just bypassing the generics type checking, and of course you would be subject to all the problems that we have when you just don't use generics. So in other words, you would just really be working with these instances that before you would specify to be a type as just instances of objects, so not really type checking at all, because any instance in Java is an instance of objects, right? Of object as a class. You see some examples of that we have already mentioned before. And I also mentioned this flag here, that is a very popular flag that you can pass to the Java-C compiler. That's just a way for us to get more verbose outputs every time that you try to compile, and then the compiler actually goes through some use of raw types. So then you're just gonna see a sort of a warning every time that's happened. If there's so these would be one example of a warning that you would get. Now let's introduce a few additional features, or a few feature things that are related to generics. And the very first one that I am going to want to show you would be the use of what you call generic methods. What is a generic method? A generic method is just methods that introduce the use of the type parameter by themselves. So we just saw in every example that we saw before, we use the diamond operator in the declaration of a class or an interface, right? So that means that every time that I would specify a member of that class or a member of that interface, I would be able to just use the same type parameter that I specified before. So if I use, for instance, K and V, I would be able to use K or V to refer to those type of parameters that we saw, right? That is not the only place where we can actually do that kind of declaration, right? So when you do the declaration in a method, which is a valid thing to do, that's when we refer to these methods as generic methods. So a generic method would be something as what you see here in this first class. So here we have a util class. I only have one method declared here, my compare method, where my key value type parameter is being specified in the signature of the method. Okay, so not really doing that in the class declaration. All right. With any class in Java, you can do that. So there's no restrictions in terms of places where you would be able to do that or not, right? So in any class, you would be allowed to go and declare the type parameters. Of course, the scope of where the use of those identifiers would happen would be only with that member itself. So it only makes sense for me to use K and V after I do that declaration in this method, right? So that will not be available to, let's say, some other members, some other methods. So we have just a similar example that we have seen before here with the K value pair, right? And here we have, in fact, I'm not sure if I think I shown a pretty similar example as this one, right? So these are just a pair where I have the key and the value as fields, and then I have two setters and two getters, right? That just retrieves or updates the keys and the key and the value, right? So with that, one thing that I could do is what you see here, where I create two instances of pairs. My two instances here are just going with the key being an integer and the value being a string, right? And then based on this compare that you see here from another class, right? So this is not the same class as the one that we are using here on pair. By the way, just perhaps a curiosity, this would be a very popular method that is an implementation of an interface that we are going to talk about when we go over collections, the collection framework. So this is similar to the compare to that we have already seen, but this one is slightly different in the sense that instead of comparing an object that I receive as an argument versus the object itself versus this, here I am receiving the two things that I'm going to compare as arguments, right? But the logic that you would see here would be pretty similar, right? So you would just be getting some field, some details of those, and then return. In this case, we return a Boolean. The actual compare of the comparable interface, that is the one that I'm talking about, would actually return an integer, same as what the compare to would do. That was the one that we have already seen before. But back to my code here that we have an example, as I said, here we have these two instances of pairs that we have instantiated, right? And then here I am calling that compare, and notice that here I am specifying what my integer and string would be, right? So here, because this method is not a method that would belong to a class that I have instantiated, right? So perhaps you would think that I do not have access to that kind of information. I do not have access to that type parameter. So then by the time that I actually invoke, by the time that I call the method, that's when I would be specifying that, right? This is partially true. In fact, it is perfectly fine for you to do that. It's legal. It does inform what you would specify as the key and value types here, right? So you can work with P1 and P2. But a lot of times, the Java compiler would also be able to do some kind of inferences, right? And one, I actually had mentioned with you already, one very popular sort of inference when I mentioned that by the time that you call a constructor of a class that uses generics, you don't really need to specify the type parameters if you have already specified with the type of the variable that is going to receive the return of that constructor call. So that's a very, very popular, very, very common way in which you would just skip defining, saying what the type parameters would be, because in a way you have already did, right? Via those type parameter specifications. So that would be another example here where I could also rely on this kind of inference, right? So in these three lines here, you see that the only modification that I did with respect to the previous lines is that I suppressed that type parameter specification, right? The rest is the same. And in this case, in this particular case, my Java compiler would be able to also infer what the types would need to be for this code to make sense, right? And what would those be? What do you think? So we already know what they need to be, but more generally speaking, how I would say that I would make these method invocation compatible with those declaration that I have on that method, that generics method. No, I mean, how would I, so for instance, what would be an example where this inference would actually pinpoint an invalid use of those instances that I intend to use? So type checking here is still happening, right? Same as in here. P1 is typed as a pair of integer and string, right? So when we declared here that I would receive a pair of key value as the first parameter and a same type pair of key value as the second parameter, I am in essence specifying that I need to pass instances that follows those. Otherwise, that would be caught by my compiler as invalid types. So when would that happen based on this code that we have here? So here, it's kind of obvious, right? It's any time that you don't have an integer and string as the type parameters of my pairs, both P1 and P2. Right? In those cases, it's just the same, right? So in other words, what my compiler here is just making sure that P1 and P2 would be typed as pairs of that integer and string that I have specified. So where is that being specified? Here, in the type of the variable that receives that new instance of a pair. All right, so that's what we refer to as that inference. And that's what allows my compiler to go and infer what the correct type here would be. So there's still type checking that is happening here, same as in here, right? And my compiler would be able to catch anytime that that's not the case. Does that make sense? Let me know if it doesn't. Any questions?
For the P2 instance, if we like swap first string and the integer, the instance would be created, right? But it would throw an error while
Yes.
comparing.
If I change that, those type parameters here, right? So if I switch, then that becomes string and integer. So now K and V are not the same as it was before. Because compare requires me to follow that, right? So this is here, the order matters, right? It's not like K and V, whatever order that I get. This is really the K followed by V for P1 and for P2. Okay, so if I don't follow that, my compiler would actually give me a compile time error and would not allow me to compile that code.
But it would still be a valid instance.
P2 by itself, yes, you can create P2, but then when you call the method, then you would not be able to proceed, right? Because now you don't have the correct matching type parameters that you would need. Okay. They do have a type. The types are K and V. They are. That's precisely when we specify. We specify here. Yes. As in any use of generics, right? When you imagine, so the previous examples, what I did when I actually wanted to create an instance of a class that was generics or an interface that was generics, what did I do? By the time that I called the constructor, I specified those types. Right? That's when you specify what the type parameters would be. Right? So, yes. Yes. In that sequence. Right? So that's what I said. The sequence here matters, right? It's not just a set of types and use however that makes sense. So the sequence here matters, okay?
So if P1 is of type string, pair of string and int, and P2 is also a pair of string and int, then that would also be a valid case.
That would, yes. That would also work because now you have those two here matching, right? So good. So as long as K from P1 and K from P2 matches and V from P1 and V from P2 matches, then we should be good.
So we can also all and also because you could potentially have the string and integer flip on the pair while having both pairs.
You mean the implementation here? Or
Down right below the declaration of the in the bool same. Down
here?
Yeah. So if you flipped that and made it sort of string integer, you couldn't use P1 or P2 in that compare. Right?
Oh, you mean I would need to update my P1 and P2 before doing that? Is that what I'm saying?
Yeah.
Yeah, you would need to come here and change. And again, that's what I said before, right? The place in this code that actually do that specification of what the type parameters are is precisely here, right? So if I come here and change, right? So then I automatically on both P1 and P2, right? So then I automatically would be able to do that following up point.
In that case, if that line has string in it, so the precedence will be taken for that, right? So that will be K would be string and
If this would be string in it, then these would be this would need to be string in it, and these would need to be string in it. Right? So if I have string in it here, I would need to have them here and here, right? For this code to make sense. Or if I mean, I could also go with that form here that I don't specify on the method call, right? So in that case, the inference would just be coming from here and from here, right? So the inference that the compiler would be doing would be by checking, okay, what's the type of P1? Type of P1 is a pair of integer and string. What is the type of P2? P2 is a pair of integer and string.
Right now we have integer and string. Say for example, we have a string or double. I mean, like where we can be explicitly typecast or implicitly typecast. In that case, can we interchange it and put it, or in that case also we have to? I mean, like say for example.
You mean for the arguments? For the arguments of the constructor, yes. Then you would be able to rely on these kind of conversion, type conversion.
In that case, util dot, I mean, like diamond brackets in that integer and string is there, right? I mean, like if we interchange it, will that work?
Let me just repeat your question and let me know if I am getting your question right. So if I use, let's say, integer and double, right? And then I come here and call the constructor, and then I pass two numbers that could be converted or understood as literal for the corresponding types, right? So they would be valid literals for the types that I specify, then you're good. That would be okay.
So basically, I mean, like we can implicitly convert the double and the string, right? So, say for example, if we interchange, like say for example, in the place of integer we put double, and in the place of string we put integer. So in that case, will that work? Because
No, so for between P1 and P2, no. So then that would not work. So what we're checking here are those types, right? So not making that kind of check. All right. So that, by the way, that would be a feature just to really make that literal compatible with is expected. So that's not the same kind of checking that we are talking about here. All right. So I would really need to have the pair of types here on P1 and P2 matching, right? Otherwise, this would not work. Did I answer your question? Good. All right, so that's that's a type inference, right? So let's just keep going with some more interesting additional like features that that we can do. By the way, I just remembered something that I was gonna ask you and I did not. Did you guys did that exercise that I asked you to do with the media box thing? Too many folders. Remember that I mentioned that exercise last time? So who did that exercise? Too much honesty going on here. All right, so okay, I'm gonna maybe assume that you guys did. Let me just go over that. All right, so you have media, right? That is a sort of a super class book inherits from media. newspaper inherits from media, video inherits from media. It's just an inheritance tree, right? And then you have library. My library has a list that does not specify what the type of each item is. Okay, so it's just a list of things for now. So there's a name to that, right? So how do you call that? A raw type, right? It's a raw type use. So list here is a raw type. So I have my resources as a array list. Have these add media that takes in as input an instance of a media. Again, media is the superclass. And then add that to my resources, right? And then I retrieve last. That is just gonna go and yes, so it's just gonna go and call size as being the size of that resources, right? And then if that size is greater than 0, that just means that that's not empty. So then I go and retrieve from resources the very last item that I have, right? That's what we are doing here. And then I cast that as a media instance, which I can, right? So it's fine. I mean, it's casting, but I would expect that to be the case, right? Because the way that we are adding is really by requiring that to be media instances. So the compiler doesn't know that, but we do. So all right, so then I return that. So how would I convert that to a code that makes use of generics, right? So you see here that on a first glance, of course, is way more compact than what we got before. So let's go over it. I have this library, generics. That is the generics version of my library, of course, that takes type parameter E, but E extends from media. So in other words, I will accept a type parameter that is a class as long as that class is a subclass of media or media itself. That's the idea that we are doing here. Yes.
It's not just classes that extend to media, but also media itself.
That's just a language specification. So extends inside the diamond operator means that can be either the type itself or a subclass of that. Okay, so that's the definition of what that keyword represents here, means here. Yes, yes. It doesn't have to be the direct one. It can be the class itself, can also be one subclass down the road. Eventually, you're gonna have some subclass, that subclasses and subclass, and then that's fine. I'm showing that example mainly because I remembered about that use of that keyword, and that's going to be related to that bounding that we can do. That's going to be one example of an upper bound. We're gonna define that in a little bit more precision a bit. So notice that here, my list now is specified as a list of E type parameter, right? So I'm just making use of that E that I have declared here, right? In array list here, I can use that shortcut that I don't need to specify the type here. That's fine, right? So if I would actually want, I could also just use E here again. My add media now takes an argument that uses the type of the type parameter as well, right? So here I don't see a lot of advantage, but here you'd see a significant advantage because I no longer would require, as I had before, a casting, right? So now my compiler would be checking for me if that would be a valid instance or not, right? So I would have a guarantee different than what we did before, right? So here in the previous example, my compiler is not checking that for me, okay? And in this case, that doesn't happen, but with an incorrect implementation, for instance, that casting could just throw an exception at runtime, and then you would have a program that breaks, right, at runtime, which is typically worse than when it breaks at compile time, because then you can still fix it and compile and be better off, right? So here, this is a better implementation because this is a more general implementation, right? So I can just make use of the same library that in this case extends from media, but I could pretty much specify whatever constraints that I would like to, whatever bounds that I would like to. So this is one example of this idea of bounded type parameters, right? What do we mean by bounds? Bounds are really just the idea of either an upper bound to the accepted types that I would pass. When is it that I pass that? When I call the constructor of that given class or interface, right? Or class that implements that interface. When I call that, I specify that, so that's when that would be checked, all right? We can see another example of that here. So here I have a box of T. I'm making some uses of T here, as you see, as we have seen before. So now here, I am using another type parameter that's actually different than this one, right? That would accept any class that is a subclass of number or number itself. So remember that with generics, the use of extends actually means not only the idea of a subclass, but also the class itself. Just a little important detail. And then here, yeah, here's nothing really specific that I'm doing, but for instance, if I would have any method that would specific to the number class, then I would allow my compiler to actually call that. Yeah.
Eventually replace number with another uppercase letter. So we can add.
No. Here, this is an actual class, right? So this is not a made up choice of a letter as I did here. Okay, so number is an actual class. No, with the syntax, it needs to be. So if you think about it, it doesn't make sense because if it is something abstract, then what are you extending? Right, so this is really to think in terms of incorporating a kind of constraint, a kind of bound that exists on some classes, right? So this would follow the idea of the typical inheritance tree, which without the bounds, I would not be able to do that, right? So without the bounds, that would just be any type. Okay, so it's like still allowing that type parameter to be specified, but it's no longer just any type. Now I'm being a little bit more strict in the sense of the acceptable classes that I can choose. All right, and this is based on actual fairly common requirements, right? As this example that I have just shown you, right? Where's as in this example here, right? Because based on the previous code, you could tell that the acceptable instances would be any class that is a subclass of media, right? That's how you came up with this whole relationship here, right? And turn that into that inheritance class relationship here, and turn that into that one single bound statement. Okay. So the typical use of generics would not be giving me that, right? Because then I would allow anything to be part of that library, right? Make sense? All right, so what are we doing here in this example? So we create okay. So this is just an error based on incorrect types, right? So we call set, and set here would be the set that follows T. So then here T would need to be integer, right? So if you set that to an instance of some integer, that's fine. But then if you call inspect, notice that inspect here would try to inspect based on not only U, but also T, right? So with T, that would mean that T would need to follow that T as a type. So that would just be giving me an error because that's not integer, integer, right? So this is a string, so that doesn't match the expected type for T, which is going to be integer, right? Make sense? So that'll be one example of my compiler catching an incorrect type use. Okay? Make sense? All right, so I can also use multiple bounds. So I don't necessarily need to specify one single bound. One thing that is interesting here is that you need to make sense of those bounds as something that also interacts with the typical inheritance tree. So with Java, because you only allow for single inheritance, that means that you cannot have more than one parent class. So then how would you specify an instance that inherits from one class, but also inherits from another class? Right? So that kind of contradicts the whole idea of single inheritance. So in other words, if I want to allow multiple bounds, I can actually only allow one single class to be one of my bounds, but then I can also add additional interfaces to those bounds. All right. So the real sort of meaning that we have here with that allowable syntax that we have is that I can specify a class as I did before, but if I would specify additional bounds here, these would need to be necessarily interfaces, right? So that's the sort of a example that you would see here. There's one additional perhaps convention that Java decided to have, which is when you have this kind of declaration, as you see here, you would need to put the class as the first bound and then the interface as the follow-up ones. Otherwise, you would get a compile time error, as you see in this example here. So this is a little bit too specific, but in case you want to use bound that incorporates not only classes and interfaces, so just remember that the class needs to be the first one.
Extend one generic type, and then you want to have like its subclass extended. If you just extend the one that is extending, it also extends the type from the original.
Say it again.
So like if you have a child class extending from a parent and it wants to extend that generic type.
Oh, you're talking about the extend applied to a class?
Yeah.
So like inheriting? That's another thing.
Or sorry.
So these are different things. So it's the same keyword, but these are completely different things.
Okay.
Right? So this is not inheritance. This extends here has nothing to do with inheritance. I mean, maybe a little bit. This is not the same as considering that these somehow can accept
Oh, I see what
so let me just rephrase that. So if I come here and create a subclass of class D, that does not tell me anything about this generic type here. Nothing, absolutely nothing. Right? So that's another extend that has a different meaning, right? So that's how I would subclass. These that I'm using here, these extends that I'm using here is just telling that other than T that would take anything, I actually have one additional constraint, one bound that is going to be okay. Instead of considering any possible class that I would accept, now I want to be a little bit more strict. I want to only accept the classes that are either that class or any subclass of that one. Right? So it's directly related to the idea of the type checking that type parameter is doing. Okay. Any more questions? Let's go. Let me actually skip here and show you what we call the lower bounded wildcards. So another Oh, sorry, actually, let me show the unbounded first. So one possible use of generics also is what you see here. When instead of going with a letter or some identifier, I could also use that question mark operator. And in the sense of the diamond operator, what I'm telling here is that I'm just allowing that to be unbounded, right? So in other words, that's just a way that would allow me to have any type checking, but still comply with the modern syntax of generics. So we talked about the raw type, which was just us not using the diamond operator at all, right? So with the use of the diamond operator, I can actually achieve pretty much the same thing, which is not have any type checking, if I go and use that question mark, right? Why is that the case? That's the case because the question mark means that I cannot reuse that as an identifier, right? I cannot just get that question mark and then put that as a return type or put that as a type of a field. I cannot reuse that. So this is really just a one-off declaration of a type, right? So that's what we call an unbounded type, right? I'm just, in a way, bypassing, same as with the raw type, but then in this case, I would actually have legal syntax. I would not get any warnings. I would not get any messages, any compilation errors, anything. All right. Is that the same thing as a raw type? No, it's pretty similar. The difference with the raw type is that you are bypassing checks that are in place. Here, I am saying that I'm not going to have any check in place, right? So when I declare the class, I don't have any of those references, right? And that's the main difference, right? So while a raw type is not recommended for you to use, it is perfectly fine to declare unbounded type parameters. Right? It just means that you don't really have a need of checking for that element to be any specific thing, right? As you see here, right? So for instance, if this can really be anything, if this can be an instance of object, right? As you see here, then fine. It's based on your requirements, right? But then if your requirements actually require any specific method from any specific class, that's another story, right? So now you need to use your bounds or just directly have those use of type parameters that we saw, okay? The T, K, whatever. So that's the unbounded wildcard. We also have the lower bounded. Let's go with that. We also have the upper bounded wildcards. So notice what we are doing here now. So here the difference is that I am still working with that question mark, right? But I'm using the extends keyword operator to specify that I am not going to, in a way, directly use that type parameter, but I still require that to be of a part of an inheritance tree. So I require it to be of a type full or a subclass of full, right? Or number or whatever, right? What does that give me? That gives me the ability to work with any instance of that type by using members, let's say methods, from a class that is full or a subclass of full. So if full would have a method that I want to use, I can assume any instance of that type parameter to have that method available.
What's the difference between wildcard extends to and T extends?
So T, you can reuse T. Wildcard, you cannot. The wildcard means I am not directly using that, that type parameter. Right? It's similar, but it's not the same, but it's similar to the idea of the role type where you don't type check. With the T, I can reuse the T, as we saw, right? Or any other letter that you choose. So with the T, I can actually check if a specific method would return really that type, if a method invocation would take in as input one instance of one of such types, and so on. With the wildcard, I cannot, that will not take place. So anytime that you have members that would require you to use the type parameter, you should not use the wildcard.
Actually, specifies the type that you're not using.
No, I mean, in this one here. So this one, I'm not using the type parameter, right? But so like I would not say that I have a member that follows the type question mark. I cannot do that, right? But one thing that I can do is if I am working with an element of that list, right, I can assume that that element is going to implement at least a method that is available from that class. So it's a way for me to kind of, it's a different guarantee that I'm getting, right? It's a way for me to make sure that I'll have some methods or fields available, right? Because then I am guaranteeing that the item from that list would be at least an instance of that given class, right? But I'm not directly using that as a type parameter. So it's a different guarantee that I am getting.